Sound recording and reproduction is an electrical or mechanical inscription and recreation of sound waves, such as spoken voice, singing, instrumental music, or sound effects. The two main classes of sound recording technology are analog recording and digital recording. Acoustic analog recording is achieved by a small microphone diaphragm that can detect changes in atmospheric pressure and record them as a graphic representation of the sound waves on a medium such as a phonograph. In magnetic tape recording, the sound waves vibrate the microphone diaphragm and are converted into a varying electric current, which is then converted to a varying magnetic field by an electromagnet, which makes a representation of the sound as magnetized areas on a plastic tape with a magnetic coating on it. Analog sound reproduction is the reverse process, with a bigger loudspeaker diaphragm causing changes to atmospheric pressure to form acoustic sound waves. Electronically generated sound waves may also be recorded directly from devices such as an electric guitar pickup or a synthesizer, without the use of acoustics in the recording process other than the need for musicians to hear how well they are playing during recording sessions. Digital recording and reproduction converts the analog sound signal picked up by the microphone to a digital form by the process of digitization. This lets the audio data be stored and transmitted by a wider variety of media. Digital recording stores audio as a series of binary numbers representing samples of the amplitude of the audio signal at equal time intervals, at a sample rate high enough to convey all sounds capable of being heard. Digital recordings are considered higher quality than analog recordings not necessarily because they have higher fidelity, but because the digital format can prevent much loss of quality found in analog recording due to noise and electromagnetic interference in playback, and mechanical deterioration or damage to the storage medium. A digital audio signal must be reconverted to analog form during playback before it is applied to a loudspeaker or earphones. Prehistory. Long before sound was first recorded, music was recorded first by written notation, then also by mechanical devices. Automatic music reproduction traces back as far as the 9th century, when the Bana Marza brothers invented the earliest known mechanical musical instrument, in this case a hydropowered organ that played interchangeable cylinders. According to Charles B. Fowler, this cylinder with raised pins on the surface remained the basic device to produce and reproduce music mechanically until the second half of the 19th century. The Banu Musa brothers also invented an automatic flute player, which appears to have been the first programmable machine. According to Fowler, the automata were a robot band that performed more than 50 facial and body actions during each musical selection. In the 14th century, Flanders introduced a mechanical bell ringer controlled by a rotating cylinder. Similar designs appeared in barrel organs, musical clocks, barrel pianos, and musical boxes. The fairground organ, developed in 1892, used a system of accordion folded punched cardboard books. The player piano, first demonstrated in 1876, used a punched paper scroll that could store an arbitrarily long piece of music. The most sophisticated of the piano rolls were hand-played, meaning that the roll represented the actual performance of an individual, not just a transcription of the sheet music. This technology to record a live performance onto a piano roll was not developed until 1904. Piano rolls have been in continuous mass production since around 1898. A 1908 U.S. Supreme Court copyright case noted that, in 1902 alone, there were between 70,000 and 75,000 player pianos manufactured, and between 1 million and 1,500,000 piano rolls produced. The use of piano rolls began to decline in the 1920s, although one type is still being made today. Phonograph. The first device that could record actual sounds as they passed through the air was the phonograph, patented in 1857 by Parisian inventor Émile de Lardla, copyright on Scott de Martinville. The earliest known recordings of the human voice are phonograph recordings, called phonograms, made in 1857. They consist of sheets of paper with sound wave-modulated white lines created by a vibrating stylus that cut through a coating of soot as the paper was passed under it. An 1860 phonogram of Au clair de la lune, a French folk song, was played back as sound for the first time in 2008 by scanning it and using software to convert the undulating line, which graphically encoded the sound, into a corresponding digital audio file. Phonograph equals phonograph cylinder equals, on April 30, 1877, French poet, humorous writer and inventor Charles Gros submitted a sealed envelope containing a letter to the Academy of Sciences in Paris fully explaining his proposed method, called the palliaphone. Though no trace of a working palliaphone was ever found, Gros is remembered as the earliest inventor of a sound recording and reproduction machine. The first practical sound recording and reproduction device was the mechanical phonograph cylinder, invented by Thomas Edison in 1877 and patented in 1878. The invention soon spread across the globe, and over the next 2 decades the commercial recording, distribution and sale of sound recordings became a growing new international industry, with the most popular titles selling millions of units by the early 1900s. The development of mass production techniques enabled cylinder recordings to become a major new consumer item in industrial countries, and the cylinder was the main consumer format from the late 1880s until around 1910. Disc phonograph equals. Your next major technical development was the invention of the gramophone disc, generally credited to Emil Berliner and commercially introduced in the United States in 1889, though others had demonstrated similar disc apparatus earlier, most notably Alexander Graham Bell in 1881. Discs were easier to manufacture, transport and store, and they had the additional benefit of being louder than cylinders, which by necessity, was single-sided. Sales of the gramophone record overtook the cylinder circa 1910, and by the end of World War I the disc had become the dominant commercial recording format. Edison, who was the main producer of cylinders, created the Edison disc record in an attempt to regain his market. In various permutations, the audio disc format became the primary medium for consumer sound recordings until the end of the 20th century, and the double-sided 78 RPM's shellac disc was the standard consumer music format from the early 1910s to the late 1950s. Although there was no universally accepted speed, and various companies offered discs that played at several different speeds, the major recording companies eventually settled on a de facto industry standard of nominally 78 revolutions per minute, though the actual speed differed between America and the rest of the world. The specified speed was 78.26 RPMs in America and 77.92 RPMs throughout the rest of the world. The difference in speeds was a result of the difference in cycle frequencies of the AC power driving the synchronous motor and available gearing ratios. The nominal speed of the disc format gave rise to its common nickname, the 78. Discs were made of shellac or similar brittle plastic-like materials, played with needles made from a variety of materials including mild steel, thorn and even sapphire. Discs had a distinctly limited playing life that varied depending on how they were produced. Earlier, purely acoustic methods of recording had limited sensitivity and frequency range. Mid-frequency range notes could be recorded, but very low and very high frequencies could not. Instruments such as the violin were difficult to transfer to disc. One technique to deal with this involved using a Stroh-violin, which was fitted a conical horn connected to a diaphragm vibrated by the violin bridge. The horn was no longer required once electrical recording was developed. The long-playing 331 or 3 RPM's microgroove vinyl record, or LP, was developed at Columbia Records and introduced in 1948. The short-playing but convenient 7-inch 45 RPM's microgroove vinyl single was introduced by RCA Victor in 1949. In the US and most developed countries, the two new vinyl formats completely replaced 78 RPM's shellac discs by the end of the 1950s, but in some corners of the world the 78 lingered on far into the 1960s. Vinyl was much more expensive than shellac, one of several factors that made its use for 78 RPM's records very unusual, but with a long-playing disc the added cost was acceptable and the compact 45 format required very little material. Vinyl offered improved performance, both in stamping and in playback. If played with a good diamond stylus mounted in a lightweight pickup on a well-adjusted torn arm, it was long-lasting. If protected from dust, scuffs and scratches there was very little noise. Vinyl records were, over-optimistically, advertised as unbreakable. They were not, but they were much less fragile than shellac, which had itself once been touted as unbreakable compared to wax cylinders. Electrical recording. Between the invention of the phonograph in 1877 and the advent of digital media, arguably the most important milestone in the history of sound recording was the introduction of what was then called electrical recording, in which a microphone was used to convert the sound into an electrical signal that was amplified and used to actuate the recording stylus. This innovation eliminated the horn sound resonances characteristic of the acoustical process, produced clearer and more full-bodied recordings by greatly extending the useful range of audio frequencies, and allowed previously unrecordable distant and feeble sounds to be captured. Sound recording began as a purely mechanical process. Except for a few crude telephone-based recording devices with no means of amplification, such as the telegraphone, it remained so until the 1920s, when several recent radio-related developments in electronics converged to revolutionize the recording process. These included improved microphones and auxiliary devices such as electronic filters, all dependent on electronic amplification to be of practical use in recording. In 1906, Lee de Forest invented the Audion Triode vacuum tube, an electronic valve that could amplify weak electrical signals. By 1915, it was in use in long-distance telephone circuits that made conversations between New York and San Francisco practical. Refined versions of this tube were the basis of all electronic sound systems until the commercial introduction of the first transistor-based audio devices in the 1950s. During World War I, engineers in the United States and Great Britain worked on ways to record and reproduce, among other things, the sound of a German U-boat for training purposes. Acoustical recording methods of the time could not reproduce the sounds accurately. The earliest results were not promising. The first electrical recording issued to the public, with little fanfare, was of November 11, 1920 funeral services for the unknown soldier in Westminster Abbey, London. The recording engineers used microphones like those in contemporary telephones, discreetly set up in the Abbey and wired to recording equipment in a vehicle outside. Although they used electronic amplification, the audio was weak and unclear. The procedure did, however, produce a recording that would otherwise not have been possible in those circumstances. For several years, this little-noted disc remained the only issued electrical recording. Several record companies and independent inventors, notably Orlando Marsh, experimented with equipment and techniques for electrical recording in the early 1920s. Marsh's electrically recorded autograph records were already being sold to the public in 1924, a year before the first such offerings from the major record companies, but their overall sound quality was too low to demonstrate any obvious advantage over traditional acoustical methods. Marsh's microphone technique was idiosyncratic and his work had little if any impact on the systems being developed by others. Telephone industry giant Western Electric had research laboratories with material and human resources that no record company or independent inventor could match. They had the best microphone, a condenser type developed there in 1916 and greatly improved in 1922, and the best amplifiers and test equipment. They had already patented an electromagnetic recorder in 1918, and in the early 1920s they decided to intensively apply their hardware and expertise to developing two state-of-the-art systems for electronically recording and reproducing sound, one that employed conventional discs and another that recorded optically on motion picture film. Their engineers pioneered the use of mechanical analogues of electrical circuits and developed a superior rubber line recorder for cutting the groove into the wax master in the disc recording system. By 1924 such dramatic progress had been made that Western Electric arranged a demonstration for the two leading record companies, the Victor Talking Machine Company and the Columbia Phonograph Company. Both soon licensed the system and both made their earliest published electrical recordings in February 1925, but neither actually released them until several months later. To avoid making their existing catalogues instantly obsolete, the two longtime arch rivals agreed privately not to publicize the new process until November 1925. by which time enough electrically recorded repertory would be available to meet the anticipated demand. During the next few years the lesser record companies licensed or developed other electrical recording systems. By 1929 only the budget label Harmony was still issuing new recordings made by the old acoustical process. Comparison of some surviving Western electric test recordings with early commercial releases indicates that the record companies dumbed down the frequency range of the system so the recordings would not overwhelm non-electronic playback equipment, which reproduced very low frequencies as an unpleasant rattle and rapidly wore out discs with strongly recorded high frequencies. Other recording formats. In the 1920s, phonofilm and other early motion picture sound systems employed optical recording technology, in which the audio signal was graphically recorded on photographic film. The amplitude variations comprising the signal were used to modulate a light source which was imaged onto the moving film through a narrow slit, allowing the signal to be photographed as variations in the density or width of a soundtrack. The projector used a steady light and a photoelectric cell to convert these variations back into an electrical signal, which was amplified and sent to loudspeakers behind the screen. Ironically, the introduction of talkies was spearheaded by the jazz singer, which used the Vitaphone sound on disc system rather than an optical soundtrack. Optical sound became the standard motion picture audio system throughout the world and remained so for theatrical release prints despite attempts in the 1950s to substitute magnetic soundtracks. Currently, all release prints on 35mm film include an analog optical soundtrack, usually stereo with Dolby SR noise reduction. In addition, an optically recorded digital soundtrack in Dolby Digital and/or Sony SDDS form is likely to be present. An optically recorded timecode is also commonly included to synchronize CD-ROMs that contain a DTS soundtrack. This period also saw several other historic developments including the introduction of the first practical magnetic sound recording system, the magnetic wire recorder, which was based on the work of Danish inventor Valdemar Poulsen. Magnetic wire recorders were effective, but the sound quality was poor, so between the wars they were primarily used for voice recording and marketed as business dictating machines. In 1924 a German engineer, Dr. Kurt Still, developed the Poulsen wire recorder as a dictating machine. The following year, Ludwig Blattner began work that eventually produced the Blattnerphone, enhancing it to use steel tape instead of wire. The BBC started using Blattnerphones in 1930 to record radio programs. In 1933 radio pioneer Guglielmo Marconi's company purchased the rights to the Blattnerphone, and newly developed Marconi still recorders were installed in the BBC's Maida Vale studios in March 1935. The tape used in Blattnerphones and Marconi still recorders was the same material used to make razor blades, and not surprisingly the fearsome Marconi still recorders were considered so dangerous that technicians had to operate them from another room for safety. Because of the high recording speeds required, they used enormous reels about 1 meter in diameter, and the thin tape frequently broke, sending jagged lengths of razor steel flying around the studio. The K1 magnetophone was the first practical tape recorder, developed by AEG in Germany in 1935. Magnetic tape. An important field of invention during this period was the tape recorder. Magnetic tape recording uses an amplified electrical audio signal to generate analogous variations of the magnetic field produced by a tape head, which impresses corresponding variations of magnetization on the moving tape. In playback mode, the signal path is reversed, the tape head acting as a miniature electric generator as the varyingly magnetized tape passes over it. The original solid steel ribbon was replaced by a much more practical coated paper tape, but acetate soon replaced paper as the standard tape base. Acetate has fairly low tensile strength and if very thin it will snap easily, so it was in turn eventually superseded by polyester. This technology, the basis for almost all commercial recording from the 1950s to the 1980s, was developed in the 1930s by German audio engineers who also rediscovered the principle of AC biasing, which dramatically improved the frequency response of tape recordings. The technology was further improved just after World War II by American audio engineer John T. Mullen with backing from Bing Crosby Enterprises. Mulline's pioneering recorders were modifications of captured German recorders. In the late 1940s, the Ampex company produced the first tape recorders commercially available in the U.S. Magnetic tape brought about sweeping changes in both radio and the recording industry. Sound could be recorded, erased and re-recorded on the same tape many times, sounds could be duplicated from tape to tape with only minor loss of quality, and recordings could now be very precisely edited by physically cutting the tape and rejoining it. Within a few years of the introduction of the first commercial tape recorder, the Ampex 200 model, launched in 1948, American musician-inventor Les Paul had invented the first multitrack tape recorder, ushering in another technical revolution in the recording industry. Tape made possible the first sound recordings totally created by electronic means, opening the way for the bold sonic experiments of the Musik concrète school and avant-garde composers like Karl-Heinz Stockhausen, which in turn led to the innovative pop music recordings of artists such as Frank Zappa, the Beatles and the Beach Boys. The ease and accuracy of tape editing, as compared to the cumbersome disc-to-disc editing procedures previously in some limited use, together with tape's consistently high audio quality, finally convinced radio networks to routinely pre-record their entertainment programming, most of which had formerly been broadcast live. Also, for the first time, broadcasters, regulators and other interested parties were able to undertake comprehensive audio logging of each day's radio broadcasts. Innovations like multitracking and tape echo allowed radio programs and advertisements to be produced to a high level of complexity and sophistication. The combined impact with innovations such as the endless loop broadcast cartridge led to significant changes in the pacing and production style of radio program content and advertising. Stereo and hi-fi. In 1881, it was noted during experiments in transmitting sound from the Paris Opera that it was possible to follow the movement of singers on the stage if earpieces connected to different microphones were held to the two ears. This discovery was commercialized in 1890 with a thorcentrophone system, which operated for over 40 years until 1932. In 1931, Alan Blumlein, a British electronics engineer working for EMI, designed a way to make the sound of an actor in a film follow his movement across the screen. In December 1931 he submitted a patent including the idea, and in 1933 this became UK patent number 394,325. Over the next 2 years, Blumlein developed stereo microphones and a stereo disc cutting head, and recorded a number of short films with stereo soundtracks. Magnetic tape enabled the development of the first practical commercial sound systems that could record and reproduce high-fidelity stereophonic sound. The experiments with stereo during the 1930s and 1940s were hampered by problems with synchronization. A major breakthrough in practical stereo sound was made by Bell Laboratories, who in 1937 demonstrated a practical system of two-channel stereo, using dual optical soundtracks on film. Major movie studios quickly developed 3-track and 4-track sound systems, and the first stereo sound recording for a commercial film was made by Judy Garland for the MGM movie Listen, Darling in 1938. The first commercially released movie with a stereo soundtrack was Walt Disney's Fantasia, released in 1940. The 1941 release of Fantasia used the Fantasound sound system. This system used a separate film for the sound, synchronized with the film carrying the picture. The sound film had 4 double-width optical soundtracks, 3 for left, center, and right audio, and a 4th as a control track with 3 recorded tones that controlled the playback volume of the 3 audio channels. Because of the complex equipment this system required, Disney exhibited the movie as a roadshow, and only in the United States. Regular releases of the movie used standard mono-optical 35mm stock until 1956, when Disney released the film with a stereo soundtrack that used the CinemaScope 4-track magnetic sound system. German audio engineers working on magnetic tape developed stereo recording by 1941, even though a 2-track push-pull monaural technique existed in 1939. Of 250 stereophonic recordings made during WW2, only 3 survive: Beethoven's Fifth Piano Concerto with Walter Gisking and Arthur Rother, a Brahms serenade, and the last movement of Bruckner's Eighth Symphony with von Karajan. The Audio Engineering Society has issued all these recordings on CD. Other early German stereophonic tapes are believed to have been destroyed in bombings. Not until Ampex introduced the first commercial two-track tape recorders in the late 1940s did stereo tape recording become commercially feasible. However, despite the availability of multitrack tape, stereo did not become the standard system for commercial music recording for some years, and remained a specialist market during the 1950s. EMI was the first company to release commercial stereophonic tapes. They issued their first Stereosonic tape in 1954. Others quickly followed, under the His Master's Voice and Columbia labels. 161 Stereosonic tapes were released, mostly classical music or lyric recordings. RCA imported these tapes into the USA. Two-track stereophonic tapes were more successful in America during the second half of the 1950s. They were duplicated at real-time or at twice the normal speed, when later four-track tapes were often duplicated at up to 16 times the normal speed, providing a lower sound quality in many cases. Early American two-track stereophonic tapes were very expensive. A typical example is the price list of the Sonotape Westminster Reels, $6.95, $11.95 and $17.95 for the 7000, 9000 and 8000 series respectively. Some HMV tapes released in the USA also cost up to $15. The history of stereo recording changed after the late 1957 introduction of the Westrex stereo phonograph disc, which used the groove format developed earlier by Blumlein. Decca Records in England came out with FFRR in the 1940s, which became internationally accepted as a worldwide standard for higher quality recording on vinyl records. The Ernest Ansermet recording of Igor Stravinsky's Petrushka was key in the development of full-frequency range records and alerting the listening public to high fidelity in 1946. Record companies mixed most popular music singles into monophonic sound until the mid-1960s. Then commonly released major recordings in both mono and stereo until the early 1970s. Many 60s pop albums now available only in stereo were originally released only in mono, and record companies produced the stereo versions of these albums by simply separating the two tracks of a master tape. In the mid-60s, as stereo became more popular, many mono recordings were remastered using the so-called fake stereo method, which spread the sound across the stereo field by directing higher frequency sound into one channel and lower frequency sounds into the other. 1950s to 1980s, magnetic tape transformed the recording industry. By the early 1950s, most commercial recordings were mastered on tape instead of recorded directly to disc. Tape facilitated a degree of manipulation in the recording process that was impractical with mixes and multiple generations of directly recorded discs. An early example is Les Paul's 1951 recording of How High the Moon, on which Paul played 8 overdubbed guitar tracks. In the 1960s, Brian Wilson of the Beach Boys, Frank Zappa, and the Beatles were among the first popular artists to explore the possibilities of multitrack recording techniques and effects on their landmark albums Pet Sounds, Freak Out, and Sgt. Pepper's Lonely Hearts Club Band. Your next important innovation was small cartridge-based tape systems, of which the compact cassette, commercialized by the Philips Electronics Company in 1964, is the best known. Initially a low-fidelity format for spoken-word voice recording and inadequate for music reproduction, after a series of improvements it entirely replaced the competing formats, the larger 8-track tape and the fairly similar Deutsche cassette developed by the German company Grundig. This latter system was not particularly common in Europe and practically unheard of in America. The compact cassette became a major consumer audio format, and advances in electronic and mechanical miniaturization led to the development of the Sony Walkman, a pocket-sized cassette player introduced in 1979. The Walkman was the first personal music player, and it gave a major boost to sales of pre-recorded cassettes, which became the first widely successful release format that used a re-recordable medium, The vinyl record was a playback-only medium, and commercially pre-recorded tapes for reel-to-reel tape decks, which many consumers found difficult to operate, were never more than an uncommon niche market item. A key advance in audio fidelity came with the Dolby A noise reduction system, invented by Ray Dolby and introduced into professional recording studios in 1966. It suppressed the light but sometimes quite noticeable steady background of hiss, which was the only easily audible downside of mastering on tape instead of recording directly to disc. A competing system, DBX, invented by David Blackmer, also found success in professional audio. A simpler variant of Dolby's noise reduction system, known as Dolby B, greatly improved the sound of cassette tape recordings by reducing the especially high level of hiss that resulted from the cassette's miniaturized tape format. It, and variants, also eventually found wide application in the recording and film industries. Dolby B was crucial to the popularization and commercial success of the cassette as a domestic recording and playback medium, and it became a standard feature in the booming home and car stereo market of the 1970s and beyond. The compact cassette format also benefited enormously from improvements to the tape itself as coatings with wider frequency responses and lower inherent noise were developed, often based on cobalt and chrome oxides as the magnetic material instead of the more usual iron oxide. The multitrack audio cartridge had been in wide use in the radio industry, from the late 1950s to the 1980s, but in the 1960s the pre-recorded 8-track cartridge was launched as a consumer audio format by Bill Lear of the Learjet Aircraft Company. Aimed particularly at the automotive market, they were the first practical, affordable car hi-fi systems, and could produce superior sound quality to the compact cassette. However, the smaller size and greater durability are augmented by the ability to create home-recorded music compilations. Since 8-track recorders were rarer, saw the cassette become the dominant consumer format for portable audio devices in the 1970s and 1980s. There had been experiments with multi-channel sound for many years, usually for special musical or cultural events, but the first commercial application of the concept came in the early 1970s with the introduction of quadraphonic sound. This spin-off development from multitrack recording used 4 tracks and 4 speakers to create a 360-degree audio field around the listener. Following the release of the first consumer 4-channel hi-fi systems, a number of popular albums were released in one of the competing 4-channel formats. Among the best-known are Mike Oldfield's Tubular Bells and Pink Floyd's The Dark Side of the Moon. Quadraphonic sound was not a commercial success, partly because of competing and somewhat incompatible 4-channel sound systems and generally poor quality, even when played as intended on the correct equipment, of the released music. It eventually faded out in the late 1970s, although this early venture paved the way for the eventual introduction of domestic surround sound systems in home theater use, which have gained enormous popularity since the introduction of the DVD. This widespread adoption has occurred despite the confusion introduced by the multitude of available surround sound standards. Audio components. The replacement of the thermionic valve by the smaller, cooler and less power-hungry transistor also accelerated the sale of consumer high-fidelity hi-fi sound systems from the 1960s onward. In the 1950s most record players were monophonic and had relatively low sound quality. Few consumers could afford high-quality stereophonic sound systems. In the 1960s, American manufacturers introduced a new generation of modular hi-fi components, separate turntables, preamplifiers, amplifiers, both combined as integrated amplifiers, tape recorders, and other ancillary equipment like the graphic equalizer, which could be connected together to create a complete home sound system. These developments were rapidly taken up by Japanese electronics companies, which soon flooded the world market with relatively cheap, high-quality components. By the 1980s, corporations like Sony had become world leaders in the music recording and playback industry. Digital recording. The advent of digital sound recording and later the compact disc in 1982 brought significant improvements in the durability of consumer recordings. The CD initiated another massive wave of change in the consumer music industry, with vinyl records effectively relegated to a small niche market by the mid-1990s. However, the record industry fiercely resisted the introduction of digital systems, fearing wholesale piracy on a medium able to produce perfect copies of original released recordings. However, the industry succumbed to the inevitable, though using various protection systems. The most recent and revolutionary developments have been in digital recording, with the development of various uncompressed and compressed digital audio file formats, processors capable and fast enough to convert the digital data to sound in real time, and inexpensive mass storage. This generated a new type of portable digital audio player. The mini-disc player, using ATRAC compression on small, cheap, rewritable discs was introduced in the 1990s but became obsolescent as solid-state non-volatile flash memory dropped in price. As technologies that increase the amount of data that can be stored on a single medium, such as Super Audio CD, DVD-A, Blu-ray disc and HD DVD become available, longer programs of higher quality fit onto a single disc. Sound files are readily downloaded from the Internet and other sources, and copied onto computers and digital audio players. Digital audio technology is used in all areas of audio, from casual use of music files of moderate quality to the most demanding professional applications. New applications such as Internet radio and podcasting have appeared. Technological developments in recording and editing have transformed the record, movie and television industries in recent decades. Audio editing became practicable with the invention of magnetic tape recording, but digital audio in cheap mass storage allows computers to edit audio files quickly, easily, and cheaply. Today, the process of making a recording is separated into tracking, mixing and mastering. Multitrack recording makes it possible to capture signals from several microphones, or from different takes to tape or disc, with maximized headroom and quality, allowing previously unavailable flexibility in the mixing and mastering stages for editing, level balancing, compressing and limiting, adding effects such as reverberation, equalization, flanging, and much more. Software There are many different digital audio recording and processing programs running under several computer operating systems for all purposes, from professional through serious amateur to casual user. A comprehensive list of digital recording applications is available on the Digital Audio Workstation page. Digital dictation software for recording and transcribing speech has different requirements. Intelligibility and flexible playback facilities are priorities, while a wide frequency range and high audio quality are not. Legal status UK Since 1934, copyright law has treated sound recordings differently from musical works. Copyright, Designs and Patents Act 1988 defines a sound recording as a recording of sounds, from which the sounds may be reproduced, or a recording of the whole or any part of a literary, dramatic or musical work, from which sounds reproducing the work or part may be produced, regardless of the medium on which the recording is made or the method by which the sounds are reproduced or produced. It thus covers vinyl records, tapes, compact discs, digital audio tapes, and MP3s that embody recordings. Notes. Further reading, Barlow, Sanny Morrison. Mountain Singing, The Story of Gospel Recordings in the Philippines. Hong Kong, Alliance Press, 1952. 352p. Carson, B.H. Burt, A.D. Rearskind, and H.I., A Record Changer and Record of Complementary Design, RCA Review, June 1949, Coleman, Mark, Playback, From the Victrola to MP3, 100 Years of Music, Machines, and Money, Da Capo Press, 2003. Gaisberg, Frederick W., The Music Goes Round, Andrew Farkas, editor. New Haven, Air, 1977. Gillard, Roland. The Fabulous Phonograph, 1877 to 1977. Second Rev. ed., being also the first Collier book set, in series, Sounds of the Century. New York, Collier, 1977. 349p, ill. ISBN 0-02-032680-7. Gronau, Pekka, The Record Industry, The Growth of a Mass Medium, Popular Music, Volume 3, Producers and Markets, pages 53–75, Cambridge University Press. Gronau, Pekka, and Sonio, Ilpo, An International History of the Recording Industry, translated from the Finnish by Christopher Moseley, London. New York, Castle, 1998. ISBN 0-304-70173-4, Lipman, Samuel, The House of Music, Art in an Era of Institutions, 1984. See the chapter on Getting on Record, pages 62–75, about the early record industry in Fred Gaisberg and Walter Legg and FFRR. Millard, Andre J., America on Record, A History of Recorded Sound, Cambridge. New York, Cambridge University Press, 1995. ISBN 0-521-47544-9, Millard, Andre J., From Edison to the iPod, UAB Reporter, 2005, University of Alabama at Birmingham. Milner, Greg, Perfecting Sound Forever, An Oral History of Recorded Music, Faber and Faber. 1 edition ISBN 978-0-571-21165-4. Cf. Pages 14 on H. Stith Bennett and Recording Consciousness. MOOGK, Edward Balthazar. Roll Back the Years, History of Canadian Recorded Sound and Its Legacy, Genesis to 1930. Ottawa, On National Library of Canada, 1975. NB in part, also, a biodiscography. The hardback ed. Comes with a phonodisc of historical Canadian recordings that the 1980 PBK reprint lacks. ISBN 0-660-01382-7, MOOGK, Edith Catherine. Title Index to Canadian works listed in Edward B. MOOGK's Roll Back the Years, History of Canadian Recorded Sound, Genesis to 1930, in series, CAML Occasional Papers, No. 1. Ottawa, Ont Canadian Association of Music Libraries, 1988. NB title and format are also in French. Supplements the index with an EBMOOGK's book. ISBN 0-9690583-3-0, Reed, Oliver, and Walter L. Welch, From Tinfoil to Stereo, Evolution of the Phonograph, 2nd ed., Indianapolis, Indiana H. W. Samond, Colorado, 1976. NB This is an historical account of the development of sound recording technology. ISBN 0-672-21205-6 PBK. Reed, Oliver, The Recording and Reproduction of Sound, Indianapolis, Indiana H. W. Samond, Colorado, 1952. NB This is a pioneering engineering account of sound recording technology. Recording Technology History, Notes revised July 6, 2005, by Stephen Schoenherr at the Wayback Machine, San Diego University, Street LaRon, Gillis, Notes on the Degradation of Sound Recordings, National Library of Canada News, Volume 13, No. 1, pages 1, 3–4. Weir, Bob, et al. Century of Sound, 100 Years of Recorded Sound, 1877–1977. Executive Writer, Bob Weir. Project Staff Writers, Brian Gorman, Jim Simons, Marty Milgwish. Toronto. Produced by Studio 123, Cop. 1977. NB published on the occasion of an exhibition commemorating the centennial of recorded sound, held at the fairground of the annual Canadian National Exhibition, Toronto, ONT, as one of the CNE's 1977 events. Without ISBN. Media, Millard, Andre, Edison's Tone Tests and the Ideal of Perfect Reproduction, Lost and Found Sound, interview on National Public Radio. External links, Audio Engineering Society, Oral History of Recorded Sound interviews with practitioners in all areas of the recording industry. British Library, History of Recorded Sound. New York Public Library, Noise in the Groove, a podcast about the history of the phonograph, gramophone, and sound recording reproduction. Audio Engineering online course under Creative Commons license. Archival sound recordings tens of thousands of recordings showcasing audio history from 19th century wax cylinders to the present day. British Library, International Association of Sound and Audio Visual Archives.